All right, today we're diving into a text that honestly tries to flip the script on some huge ideas we have about wind power, physics, and, well, even how airplanes fly. Now, I have to say this right up front. What we're about to explore is a huge departure from what mainstream science says. The source basically claims the core calculations everyone uses are just flat out wrong. So let's get into it.
And it kicks off with this incredibly bold statement from a document called Windkraft Neue Denkansätze und Irrtümer. Basically, it's saying to forget everything you think you know about those massive circles wind turbines make in the sky. According to this text, that whole idea is a fundamental mistake.
Okay, so first things first, we've got to unpack that central claim. I mean, if the giant radius of the rotor isn't the right way to think about how much power is being generated, then what is? You'll see this one idea creates a massive ripple effect through everything else.
And that's the big question the source wants us to ask. You know, the standard model has been around for decades, but this author is arguing that we've been looking at the wrong thing the entire time. We're measuring all this empty space instead of the actual object that's doing the work.
Now check this out. On the left, you've got the conventional method, which uses the entire area that the blades sweep through, that huge circle, for its power calculations. But the source says, nope, that's totally irrelevant. The only thing that actually matters is the physical surface area of the blade itself. You know, its length times its width. All that air passing between the blades, this model says it's untouched and it doesn't belong in the calculation at all. And here's the domino effect, right? If you buy into step one, that only the blade's surface area matters, then adding more blades, as the source calls it, is just nonsense. It doesn't really increase the total force. And from there, the idea that spinning the blades faster captures more wind, well, that doesn't make sense in this model either. The blade is supposedly already dealing with all the air pressure it can.
So let's follow this train of thought. The next piece of the argument redefines the basic physics of how something even interacts with the wind. It boils it all down to a really direct relationship.
The source calls it the plus-minus effect, and it's a pretty simple concept, really. If you're moving against the wind, you're adding pressure. That's a plus, you're fighting it. If you move away from the wind, you're subtracting pressure. That's a minus, you're getting pushed by it. It's just a direct back and forth between the object and the air. So here's the crucial takeaway from that idea. If the only thing that matters is the surface area hitting the air, the relationship becomes totally linear. According to the source, a blade that's 2 meters wide will capture exactly twice the energy of a 1 meter wide blade. Simple as that. It's a direct one-to-one thing. No complicated aerodynamics, just basic mechanics. And this leads to one of the most, wait, what? Claims in the whole text. I mean, why build these ridiculously tall turbines? The source argues that at super high speeds, the tip of the blade is moving so fast that it's actually running away from the wind pressure that's supposed to be pushing it. So it actually becomes less efficient than a slower blade closer to the ground.
To make its point about forces, the source uses a car as an example. You might think a car has to deal with a double wind load. You know, the pressure on the front and then the drag or vacuum on the back. The author just says, no, it's not two different forces, it just looks like it. High pressure in the front and low pressure in the back are just two sides of the very same coin. There's no reason to calculate it twice.
And this is where the theory really goes for it. It expands way beyond wind turbines and makes maybe its most audacious claim yet. The source uses these same principles of air pressure to challenge the century-old understanding of how planes even fly.
I mean, wow, that's a direct shot at the heart of modern aerodynamics. The Bernoulli principle, that whole idea of the curved airfoil making air move faster on top to create a pressure difference, the source just calls it an error, a complete misunderstanding of flight. This slide just lays out the two worldviews perfectly. On the left, you've got the textbook explanation we all got in school. But on the right, the source's theory is, well, it's way simpler. It's not about airflow. It's about a solid thing, the wing, pushing its way through a stationary medium, the air. The angle of that wing creates a low-pressure zone behind it, and that imbalance is what gives you lift.
And you really have to flip a switch in your brain to get this part. In this model, the air isn't this fluid thing flowing over a wing. The air is still. It's the wing that's the active part, muscling its way through the air and leaving a sort of vacuum behind it. And to really drive this point home, the source gives this pretty wild thought experiment. If lift is just about the wing's angle creating low pressure behind it, then the shape of the back of the wing doesn't really matter that much. It claims you could literally hammer nails into the back of the wing, and as long as they aren't facing the wind, they wouldn't really affect the lift.
So after taking apart the rotor, redefining pressure, and reframing the whole theory of flight, what are we left with? What are the big takeaway principles from this totally different way of seeing the world?
And here they are, all wrapped up. 4 huge challenges to conventional physics from this one text. First, power is all about surface area. Second, lift is just about angle and displacement. Third, air is static. And finally, force is a single thing. You know, whether you agree with it or not, it's a completely self-contained alternative viewpoint.
And that brings us to the end. Look, the point today wasn't to prove or disprove these ideas, but just to explore them. Because they really make you think. This source, in its own radical way, is a great reminder that even the most established scientific facts were at one point just new, strange ideas. It kind of leaves us with a cool question to think about in our own lives. What are the things we just assume are true? And what might we see if we looked at them from a completely different angle?